C respectively. Respectively. Is this okay? Tau A, tau B, and tau C respectively. The torque are, compare them. Compare tau A, tau B, and tau C. Do it fast. So let's do it. So what is the torque on A? Can you say me? Torque on A will be equal to mod F mod R1 sin theta 1. Suppose this is theta 1. Then this angle is also theta 1. So that is the vector, that is the angle between these two vectors. Isn't it? So sin theta 1. This is theta 2, this is theta 3. Now tau B is equal to force into mod of R2 into sin theta 2. Tau C is equal to mod F into mod R3 into sin theta 3. Now we have to compare tau A, tau B, and tau C. Is this all right? If we have to compare tau A, tau B, and tau C, how we can compare them? So what is R1 sin theta 1? Can you tell me? This distance is basically R1 sin theta 1. This distance is R1 sin theta 1, that is H. What is R2 sin theta 2? This distance is H, that is R2 sin theta 2. And this distance is H, that is R3 sin theta 3. Is this okay? Hope you understand. So this is equal to F into H This is also equal to F into H. And this is also equal to F into H. Hope you understand. So all torque will be equal to, so tau A will be equal to tau B is equal to tau C. Hope you understand. So their torque will be equal. Is this all right? Copy it. So basically from this place, you get another definition of the torque. What are that definition? And that we have to use generally. Suppose F force is acting in this direction and this is R vector. Then the torque about this point is what you have to do? Just you have to draw the line of force. Is this okay? Line of force is the force, is the line along which the force is acting. This is the line of force. So first of all, draw the line of force and draw a perpendicular to the line of force from axis of rotation. So if this perpendicular distance is d, then torque will be equal to force into d. Force into this perpendicular distance. Hope you understand. Is this all right? As for example, suppose if this is the rod, a hinge at this point. Suppose F force is acting at this place, that is 50 Newton. And suppose this length is 1.5 meter. What is the torque? So torque will be equal to, this is the line of force and the perpendicular distance is 1.5. So that is equal to 50 into 1.5. That is equal to 75 Newton meter. Hope you understand. Is this all right? Do it first. Now, so suppose this is the rod and this is hinged at this point. The length of the rod is L or L naught. One force is acting at this place, that is F. Another force is acting at the center, like this, at angle of 37 degree. That is equal to F. Is this all right? Find net torque on the rod. Net torque acting on the rod. Do it first. So, okay, let me tell you. So this is the force, this is the line of force, and this perpendicular distance is this one, L dot. And here this one is the line of force, and perpendicular distance is this one. So you have to calculate this perpendicular distance, which is very easy to calculate. This is actually, this length is L naught by 2, and this is 37 degree. So what is that perpendicular distance? This perpendicular distance is basically L naught by 2 sine 37 degree. Is this all right? Now that will be equal to L naught by 2 into sine 37 is 3 by 5. So torque of this force is, torque net is equal to torque of this force is F into L naught. Torque of this force is F into 3 L naught by 10. Is this okay? So that is equal to 1.3 F into L naught. Hope you understand. This is the net torque. Now you can see this force has tendency to rotate it clockwise. This force will also rotate this rod in clockwise direction. So both torque will be added up. Suppose if the sense of the force is to move in anti-clockwise direction, then you have to take negative sign for that torque. Is this okay? We will do the illustration. You will get that thing. So suppose next question is, this is the hinge point. Length of the rod is L naught. At the midpoint, the force is F. At this point, the force is 2F. This angle is 53 degree. And at this point, there is a force of 4F Newton. Find net torque about the axis of rotation. Is this okay? Do it. So let's discuss it. So what is the torque of this force? This is acting in downward direction like this. So this is the line of force. Perpendicular distance is clear, that is equal to L naught by 2. And so torque is equal to, so, and it is rotating it in clockwise direction. So take it positive, F into L naught by 2. Now 4F. So 4F, if you draw the line of force, it will pass through the axis of rotation. So what is the perpendicular distance from axis of rotation to the line of force? That is 0. Because line of force is itself passing through the axis of rotation, then its perpendicular distance to that line will be 0. So its torque of this 4F Newton will be equal to 0. So try to remember it from today. If the force tends to pass through the axis of rotation, then its torque is 0. Is this okay? Now, the torque of this one, this 2F force. So which one is the line of force? Line of force is this one. Draw the perpendicular distance from it. This is the perpendicular distance. So this distance basically you should find. If this is 53 degree, this is also 53 degree. And if this is L naught, this length is L naught cos 53, and this distance D is L naught sin 53. Hope you understand. So that will be equal to 4 L naught by 5. Is this okay? So its torque will be in negative direction, and that will be equal to twice F into 4 L naught by 5. Hope you understand. Is this okay? So torque net will be equal to F into L naught by 2 minus 8F L naught by 5. So this is 10. This is 5F L naught minus 16F L naught. So that is equal to minus 11 F L naught by 10. Is this okay? So torque is coming negative. It means that rotation will be anti-clockwise. Is this okay? Rotation will be anti-clockwise direction. Try to do all these things at your home also. Is this okay? You have to do it. Once you have to do it at your home. Is this all right? Good. Suppose this is the desk and this center is axis of rotation. This is basically axis of rotation. Suppose a tangential force of 50 Newton act in this direction. Its radius is 1 by 2 meter. Another force of 50 Newton is going through the center, isn't it? And find net torque about the center or about the axis. Do it fast. This is a square. This square is hinged at this point. Hinged at this point. Side length of a square is L naught. Is this okay? So here the F naught force is acting. Here from the midpoint, this is twice F naught force. And In this direction, along the diagonal, the force is F naught. Find net torque about the hinge point. Do it fast. So let me discuss. So this is the axis of rotation. This is the force acting on it, 50 Newton. Here is also the force, 50 Newton. So it is passing through the center. Since this is passing through the center, so its torque will be 0. Its torque will be 0 plus torque of this 50 Newton will be equal to 50 into half. That is equal to 25 Newton per meter. Newton meter. Is this all right? Because this is perpendicular distance. Now, a square. So what is the torque of this force? This force. This is the line of force, perpendicular distance is this one. So what is this distance? So diagonal is root 2 L naught. So this is root 2 L naught by 2, isn't it? So the force, torque of force F naught is in clockwise direction because F naught has tendency to rotate in clockwise. You can say it and decide it, isn't it? Suppose this is a square, only F naught is acting. So in which direction this will rotate? In clockwise direction. So torque will be equal to F naught into root 2 L naught by 2. Is this all right? Plus this is in clockwise. Now this is F naught. So this is the line of force. Perpendicular distance is L naught. So it will also rotate in clockwise. So it will be plus F naught into L naught. Now this 2 F naught. So this will pass like this, isn't it? So this length is L naught by 2. Is this okay? So it will rotate this square in clockwise, anti-clockwise direction. So that is minus 2 F naught into L naught by 2. So it will be cancelled out. So F naught, L naught, F naught, L naught will cancel out. So net torque will be equal to F naught into root 2 L naught by 2. Is this okay? That is the answer. Hope you understand. Now, another type of question is, suppose if force vector is equal to alpha I cap, or force vector is equal to 5 I cap minus j cap plus k cap. R vector is equal to minus I cap plus j cap plus k cap. Find torque vector. Do it first. And its magnitude. Do it first. So just you have to take cross product for this question. So we know that torque vector is equal to R cross F vector, isn't it? So I told you how to take the cross product. It is all right. Now by determinant method also you can take the cross product by determinant method. So this is I, this is J, this is K. So I cap R cross F, so its coefficient is -1, 3, and 1. Its coefficient is 5, -1 and 1. So if you open it across it, I told you how to take cross product. So I cap, this is cross multiplied like this. So this will be 3 minus minus plus 1 minus J cap into 1 minus 1, that is -1 minus 5 plus K cap, that is equal to 1 minus 15. Is this all right? So that is equal to 4 I cap minus plus 6 J cap minus 14 K cap. Hope you understand. This is the torque vector. And what is its magnitude? Magnitude of this torque will be equal to 4 square, that is 16, plus 6 square, that is 36, plus 14 square, that is 196 root under. Hope you understand. This is going to be the magnitude calculated. So today up to this, okay, we studied how to find torque today. In the next lecture, we will study moment of inertia. That is also very important topic. So revise torque once again at your home. Is this okay? And do some more practice on finding the torque value. Isn't it? It will be benefited in the next lecture.
Yes.
Okay. Bye. Take care.
Thank you, sir.
Thank you.